Okay, we're working on our second practice problem when it comes to the equation method. And go ahead and pause this and write it down before I get started. 50% of what number is 37? Always, always, always the first step is identifying the part, the whole, and in this case, the percent as a decimal. Don't get tripped up there. That's the biggest key between the proportion method and the equation method, is that in the equation method, you need to convert the percent into a decimal. So why don't we do that right now? How do I convert 50% into a decimal? Well, 50% equals, as a decimal, I just need to move the decimal place over to the left 2 times. 1 time, 2 times. So 0.5 or 5/10 is going to be my percent as a decimal for this problem. So 0.5. It says of what number? Remember, the of is our key indicator, and that's going to tell us where our whole is, or our total. And right now it says what number. So we don't know what that is, so we're going to leave that as x. Process of elimination, that means 37 has to be our part. So great, I've got all my components. Let's write our formula, our equation. Part equals whole times percent as a decimal. Let's fill it in. We laid it out so nicely here just so that we could fill it in. So our part is 37. Our whole is x. And our percent as a decimal is 0.5. Okay. This one's a little bit different than the one we did first, because this one we actually do need to solve for x. We need to isolate x. Right now, x is embedded in that 0.5. It's being multiplied by 0.5. So we need to get x by itself. In order to do that, we need to do the opposite operation of multiplying, which is division. So I'm going to divide this whole thing by 0.5 so that my 0.5s drop out and leave me with x all by itself. But if I divide by 0.5 on the right side, I got to do the same thing on the left. So I'm dividing by 0.5 on the left side. So now this turns into a division problem. And remember, when we're dividing, the top number always goes inside the box. So the 37, notice I gave myself a little extra room here. I'm going to come back to that in a second. 37 goes in the box because it's on top, and 0.5 goes on the outside. Cool. Remember, our rules for dividing decimals is that if there is a decimal outside the box as a divisor, we need to get rid of that decimal by moving it over however many places. So we're going to hop and pop. So we're going to move it over 1 time. But if we move it over 1 time on the outside, we got to do the same thing on the inside. But right now, there's no decimal point or any places to go. So I'm going to add a couple zeros. So I haven't changed anything yet. I haven't moved my decimal. I just placed it where it's supposed to go, and I add some decimals. And because I moved it over 1 time on the outside, I got to do the same thing on the inside. So I'm going to move it up 1, hop it, and pop it. Remember, wherever the decimal ends up, that's where your decimal is going to be in your answer. Okay, so now we're ready to divide. Does 5 go into 3? Nope. Does 5 go into 37? Yes. It goes in 7 times. 7 times 5 is 35. I'm subtracting. I get 2. Bring down the 0. And I start the process over again. How many times does 5 go into 20? It goes in 4 times. 4 times 5 is 20. I got nothing left over, nothing to bring down because it would just be zeros forever. So I am done. So my answer after that division problem is 74. And that's the overall answer to my problem. 50% of 74 is 37. And another way you can think about this problem is 50%, that means like cutting it in half. So if I cut 74 in half, my whole, I would end up with 37.